This is Daniel Ferguson, and today we're going to do another simple part just to give you some more introduction and some more functionality and a little bit of the SOLIDWORKS tools that go with it. So let's go ahead and get started. You'll notice I have a brand new part in SOLIDWORKS, nothing on the screen right now. So the first thing we're going to do is go to the Extract 3D tab on the right, use the Import Mesh on the left side, and I'm going to go ahead and pull in a quick sample of a little sprocket gear. Oops. Not in here. So what we've got here is a simple sprocket. We've got teeth on the outside. We've got some spline broach profile on the inside. This is another example of one of those parts that would be very, very difficult to reverse engineer if you didn't have a 3D scan. But we'll show you just how easy it is to do with the 3D scan and the Extract 3D functions here. So let's go ahead and get going. First thing I'm going to do is create the exterior kind of 3D portion of it, the revolve function, or the revolve features here. So I'm going to pick a plane right there down the middle, and we're going to use the slice function to slice through the 3D scan just like that. And I'm going to hide the mesh. So I've got a reference curve of the boundary of the mesh shown right there, and I'm going to go ahead and use that same plane to create a sketch in SOLIDWORKS. So we're going to use our standard sketching functions in SOLIDWORKS to start drawing out all these features. Make a tangent line there, line, tangent arc there, and line straight down. Okay, I'm just kind of sketching these roughly in the right position, and we'll go back and adjust those later. Actually, this one I'm going to get a little closer. So I'm going to do a tangent arc. Now, I'm going to do something a little unique. On the inside here, I'm actually going to make sure I have extra material because we're going to be cutting that out later. So right here, let's see where I'm working right in here. Go ahead and make sure I have extra material in this surface here. Actually skipping away from the line. And get that last set of curves on the bottom. Okay, crossed, up, place, and a tangent arc oversized to there, just like that, and make sure those guys connect there. Okay, so getting pretty close. I've got all the I've got the rough shape kind of drawn in there, and now I'm going to go through and adjust these things just a little bit at a time, just like that, and get that fairly close. And you'll notice there's actually a tool in the Extract 3D tab called, if you actually select a line, you have the option to fit. And you'll see what that fit does. It actually takes that straight line and it fits it to the red scan data. We can do the same thing down here. Let's pull this kind of close. We'll do a fit. Get that close. Fit. And then pull this over here. Pull this down like that. And get that one to fit. Just like that. So that's kind of a nice little feature that allows you to get pretty close, but if you want some confidence, just hit it like that. All right. There. I don't have any dimensions on this just for the sake of demonstration, but if you wanted to, you can go through and add your dimensions at this time. So maybe we might want to define the overall height here at 28 millimeters, for example. We can go through and define the ones that we want, and then go and use the Extract 3D to fit the remaining curves to the right spot. So I'm going to go ahead and clean that up just a little bit, get that a little closer. And I think I've got it where I want to go. And I need a center line down the middle, right there, that we can revolve it around. And there we go. So we've got our sketch. We've over-trimmed, so there's a little bit of extra material on the inside. Matter of fact, I might even do the outside the same. Get a little bit of extra material so we can cut that away later. And here we go. And a revolve base. Just like that. Okay, so step one was to create this kind of 3D revolved feature around the exterior of the part. Done. And the next thing is we're going to start working on the sprocket, the teeth itself. So let me put that mesh back on, and I'm going to do another slice. And this time I'm going to go right through the center of the part, just like that, and pick that plane and hit the slice button. And so here I've now switched to the center axis, or the center plane. We've got another slice, and we're going to start working on the exterior of the teeth. And to do that, I use this as a sketch plane, hit the sketch function, and here we go. And so the way that I like to make teeth, and I'll just kind of walk you through this, is I like to take a single tooth and then pattern it around the perimeter. And the easiest way to do that is to draw a line. And let's draw a symmetry line. It doesn't really matter which tooth you use. If you're working with 3D scan data, sometimes it's best to just get the cleanest scanned tooth. Sometimes they scan really well. Sometimes they're harder to see. They might get noisy or gummy. And let's define a circle for the center to the root, the center to the tip, just like that. And get that a little closer. Make sure that I'm looking at the part straight on like that. Okay. Alright, so there we go to the root, right to the tip. And get that roughly in the right spot, and now here we go. So the correct way to make involute splines like this is actually to use the equation-driven curve, that define those in a complicated formula, and then you actually get a curve that follows it. In this case, for the demonstration, I'm just going to use a standard spline and just kind of draw it and eyeball it in the right location. This actually works pretty well for the most part. You're going to get splines that are pretty close, probably good enough to run a gear, but if you're really picky about it and you're really using that to define the shape of your brooch, you're going to want to use this equation-driven curve to do that. But let's go ahead and pull these into location. There we go. So you'll see I'm just kind of adjusting this until it fits extremely tight to the original curve. Just like that. And now I'm going to go ahead and mirror that over to the other side using the mirror entities. And we're going to mirror this curve, and we're going to mirror it on this line. And you'll notice it didn't quite land on the line. And the reason I did that is because I defined a center line off the axis, and now I can go ahead and adjust this just like that till it lays right in the right spot. And this helps me for, this kind of prevents me from trying to guess where the actual center line of that is, and then use the scan geometry to kind of make sure that that ends up in the right spot. So I now have a profile that I can cut out of this thing. I'm going to add some a little bit of extra material here on the outside, like that, out. And we're just trying to make sure we've got one tooth fully profiled, and I'm going to use the power trim to clean this up and make a volume that we can actually cut apart, just like that. Okay, so you'll see I've kind of created this odd little tooth, and I'm going to use that to cut my gear. So let's go ahead and do a feature. And we're going to use an extruded cut all the way through the part. I want to make sure I go the other direction as well to make sure I get a little flange on the top. And there we go. So I've cut one tooth, but you'll see I've got quite a few more. So the next stage is to use the circular driven pattern, just like that. And I'm going to use the center axis. And I want to do these features just like that. Okay. Okay, we're going to kind of guess the number of teeth. And you'll notice that the yellow lines, those are the ones that are going to come out of the pattern, and the red lines don't quite match up because I have the wrong number of teeth. I'm going to adjust this until they line up. 19, 18, there we go. So that's exactly 18 teeth. I didn't even have to count, it just showed up. And we're going to cut that with the pattern, and there we go. Okay, so we've just cut the exterior tooth profile on the gear. And now I'm going to do the exact same thing for the inside, and I'll just use this exact same sketch plane. I'll sketch right on top of that. Get that a little bit closer there. And I'm going to use the same process I used before. I start by creating a kind of an axis there to define this circular portion right there. Draw a center line on one of these teeth. Doesn't really matter. We're cutting out material right there. Put it right about there. And I'm going to use a center point arc to kind of define wrong side. Pull that in just like that. We're trying to get this on top of the 3D scan. We'll use that scan to kind of set our dimensions and get the shape just the right way we want it. Pull that in Right, like that, okay. And now I'm going to go ahead and take a tangent arc to trim that out. Tangent arc. Take that out to there. Take this one, do the same out to there. A little bit of adjusting on this guy. Let's get that. Okay. Okay, so I've created my little tooth cutout, and I want to make sure that I get some material all the way out. So go all the way to the boundary. So I'm kind of defining a little plug that I'm going to use to cut out the material. Looks like that. And now we power trim and get rid of all the excess curves, just like that. And that'll go away as well. Don't need that anymore. So I've just created a little plug here I'm going to use to cut out and remove the material from the inside of the ring. So go ahead and exit the sketch and use the extrude cut feature right here to extrude a cut all the way through. Okay, so there's my first little notch cut out. I'm going to do the same as I did before. Use the circular pattern on this center axis. And you'll notice that the 18 doesn't quite work, so I think there's a few more spline teeth on there, so I'm going to keep kind of cycling through until I find the magic number. It looks like 27 teeth does it. So there we go, 27, and that's it. Just created that little spline feature on the inside, and there we go. Look at that. Go ahead and go back to the extract feature, get rid of the slice, and you'll see there's my 3D scan. On the background, and there's my mesh, and there's my cat, just like that. So that was about 10 minutes, start to finish, and here we've got a brand new spline.